Okay, so this video is covering section 5.3, and up to this point in the chapter, we've been dealing with an angle in standard position. So kind of like what we would see over here, where the angle's in standard position, the initial side is the x-axis, and the terminal side is somewhere else. And we've given the sine, the cosine, the tangent, all the trig ratios in relationship to x, y, and r, thinking about how this point up here, point B, we could define that as the coordinate would be x comma y. And so we think about the sides of the triangle as being x and y. Sometimes they're negative, sometimes they're positive. R, of course, the hypotenuse, which of the right triangle, but it is the distance from the origin to that point, all right? And that's always positive. But we often are going to look at triangles that are not part of a Cartesian coordinate system. Instead, it's just going to be a triangle like you would have seen in geometry. So we're going back to and thinking about SOHCAHTOA. SOHCAHTOA doesn't always work well in the situation of the Cartesian coordinate system, but it does work pretty well when we're just talking about a random right triangle. All right, so in a right triangle, typically we're going to call C the right angle, and capital A and capital B, which are either vertices or angles, those are going to be the acute angles of the right triangle. And then we use the small letter B to designate the side, the length of the side opposite the angle B, and little a to denote the length of side A opposite angle A. Okay, now here we've also called angle theta. Angle A is also called angle theta, just to kind of mirror what we've got over here, but realizing, of course, that we can call these things other things as well, but we'll often just call this angle A and this angle B. Angle C is a right angle. Okay, and then the small letter C will denote the length of the hypotenuse, again, opposite the right angle. Okay, so in terms of this sort of random right triangle, right, if you have sine of A, well, that's going to be A over C, or the opposite leg from angle A divided by the hypotenuse. Cosine of A will be the cosine of this angle A will be the adjacent leg divided by the hypotenuse, and then tangent will be the opposite leg over the adjacent. So opposite over adjacent. Okay, now I have them listed here because they're just simply the reciprocals of this. But when we have these sort of triangles here, we almost never use cosecant, secant, and cotangent because these are not, you can't do these really directly in your calculator. All right, so you can't use your calculator to do these. You can certainly do the reciprocal of sine, you can hit your reciprocal button, but these are not directly buttons on our calculator. So when we're doing this, we often will be using our calculator, and so we don't often do cosecant, secant, and cotangent when we have these just generic right triangles, not part of a Cartesian coordinate system. Now also, now we did all of these up here in terms of angle A, but we could certainly do sine of angle B. It's the opposite over the hypotenuse. So what you should not do is memorize that sine is always A over C, cosine is B over C, and tangent is A over B, because it's not. It depends on what angle you're dealing with. So don't concentrate on memorizing, the sine is A over C, or the cosine is B over C. It really depends on what angle you were talking about, and you have to really memorize them in terms of the opposite leg over the hypotenuse, that's sine. Cosine is adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg. So concentrate on those. Every year I have a couple of students who memorize this and think that it applies to any sine. Sine is always A over C, and it's not. All right? It is for this angle, because for this angle A, A is the opposite side, C is the hypotenuse. Okay. What else? Okay, so SOHCAHTOA. So we're getting back to SOHCAHTOA, and the SOHCAHTOA means that it's just a mnemonic to help us remember that sine is the opposite over the hypotenuse cosine is adjacent it's hard to write down over hypotenuse and that tangent is opposite over adjacent. Okay, so that might be helpful. I tried to discourage you from using SOHCAHTOA back over here because it doesn't always work. In this situation up here, we never talked about this angle up here. We only talked about the angle down at the vertex. Here, we can talk about any of the angles, either one, really. We don't ever really talk about C because we always know that's a right angle. But we can talk about A or B. Here, we always refer to the lower angle, the angle formed with the hypotenuse and the x-axis. Okay. All right, let's look at example 1. Find the following trigonometric ratios. All right, so the first thing we have to do is we have this triangle, we need to find this missing side. And so we would use Pythagorean theorem. And it ends up being a triple. So 20, 21, 29 is a triple. And so now what is the sine of D? So the sine of D. Sine is opposite over hypotenuse. So this will be 21 over 29. And then sine of F, so that's up here, F, that's this angle. So we want to talk about the opposite over the hypotenuse. So in that case, it's 20 over 29. Let's move over and do the cosine. Cosine of F, that's the adjacent, which is 21 over 29. And then let's do, sort of doing these out of order a little bit. Tangent of F. Tangent of F, remember the tangent is opposite over adjacent, so this will be 20 over 21. Tangent of D, opposite over adjacent, so 21 over 20. And then cosine of D, that's adjacent over hypotenuse 29. So you notice that the sine of one of the angles is equal to the cosine of the other, right? I'm going to forego these down here. Again, we don't really use them very often when we're dealing with right triangles, not part of Cartesian coordinate system. But these would simply be the reciprocals of the ones up above. Okay, let's move on. So we had some special right triangles in geometry class. We had a 30, 60, 90, and we had a 45, 45, 90. This one might also be called an isosceles triangle, right? Isosceles, I guess, isosceles right triangle, right? So we have, if we say that, we know two angles are the same. So we know if two angles are the same, remember the converse of the isosceles triangle theorem, two angles the same, then two sides must be the same, okay? So we're going to talk about and use these angles a lot, 30, 45, and 60. We saw them already a lot when we were dealing with the Cartesian coordinate system. It's a way of asking you to give me exact answers. So for when I give you 30, 60, 90, 45, 45, 90, you would not be using your calculator for these. You'd be giving me exact answers. So remember the rule for a 30, 60, 90 is the short leg is half the hypotenuse. So this is 1, this side is 2, it's double it. And then we take that side and multiply by the square root of 3 to get this side. So this is 1 times the square root of 3, or just the square root of 3. And then for this one, these two are the same, so y must equal 1. And we take that side and multiply by the square root of 2. So this is equal to the square root of 2. All right, so we want those as exact values. We don't want a decimal. We don't want you to use SOHCAHTOA for those. You should just know the relationship. So here, all of these are special right triangles. Be careful they're not drawn to scale. Pause this video, do them all, and then start up the video again. Okay, so this is the short leg because it's opposite the 30-degree angle. So that means this is the hypotenuse. That's got to be 10. This has got to be 5 times the square root of 3. So we take that and multiply by square root of 3 to get the longer leg. Don't go by how they look. Go by how they're marked, because we often will not draw these to scale. So just be cautious. All right, this one is a 45, 45, 90, even though they don't address it. These two sides are the same. These two angles are the same, so they have to be 45s. Okay, so this is, x here is going to be 6, and this is going to be 6 square roots of 2. All right, this one, be careful. This is the hypotenuse. Where's the short leg? Well, it's here because this has to be 30 degrees since that one is 60. So this is half of this. And now I can take the short leg and multiply by square root of 3. So 5 square roots of 3. On this one's a 45, 45. I know that because if this is 90 and that's 45, this also has to be 45 degrees. All right, and so now to go this way, we multiply by square root of 2, but to go the other way, to get the legs, we divide by the square root of 2. So x is equal to 10 divided by the square root of 2. Well, really, that's just going to be what? I multiply top and bottom by square root of 2, and then I simplify the 10 with the 2. So that's 5 square roots of 2. So we cut the 10 in half and put a square root of 2 behind it is kind of the shortcut. And then also you can always check, well, if x is 5 square roots of 2, if I multiply by square root of 2, I get 10, right? And so y is the same thing, 5 square roots of 2. All right, this one, be careful, is 6 the long leg or the short leg? Looks like the short leg, but I know this angle is 60 degrees, so you can't go by how they look. This one looks like the 60, but they told us that was the 30, so this is the short leg. So to get the short leg, I divide by the square root of 3. So 6 divided by the square root of 3 is what x is equal to. So of course we want to simplify that. So that's going to be 2 square roots of 3. So x is 2 square roots of 3. And you can check that by multiplying by square root of 3. And does that give me 6? Yeah. Now we want to double that to get our y. So that y is going to be 4 square roots of 3. All right, last one. We know the hypotenuse. X is the short leg, not because it looks like it, but because it's opposite the smaller angle. So how do we get that? We just cut it in half. So that's 6 square roots of 3. Half of 12 square root of 3 is 6 square root of 3. Now I multiply by square root of 3. So 6 square root of 3 times the square root of 3, well, that's 18. All right, let's go on to page 2. All right, so on page 2, we simply want to fill in this table, and these are here to help us, help guide us through, like, how do we find the sign. So you don't have to memorize these. You know, you might sort of memorize these 9, right? These 3 angles are so important. Do you have to memorize these? No, but it might be helpful to at least know these 9, or at least be comfortable enough so that you can, like, oh yeah, I know what that is. Okay, so let's start with the 30. This one is 30 degrees up here. We're going to use that, and this one is 60 degrees. We'll call this one 45 degrees, and 45 degrees, and 90, just to help us kind of look at the sides. All right, so so this one is 1, 2, square root of 3. This is 1, 1, square root of 2. Or any ratio. I mean, I could say this is square root of 2, and this is square root of 2, and this is 2, right? I mean, there's lots of different, these are just the basic, smallest, simplest numbers that work in these triangles. All right, so the sine of 30, remember that's opposite over hypotenuse, that's 1/2. Cosine of 30, adjacent over hypotenuse, the square root of 3 over 2. The tangent of 30, that's opposite over adjacent, so that's 1 over square root of 3, but that's square, once I simplify that, square root of 3 over 3. All right, 45, sine of 45, that's opposite over hypotenuse, 1 over square root of 2, but of course we're going to square root of 2, so that's square root of 2 over 2. All right, we're going to simplify that, square root of 2 over 2. And then cosine, same thing, square root of 2 over 2. Opposite is the same for both of those. And then tangent, that's opposite over adjacent, that's just going to be 1. 60 now. Sine is opposite over hypotenuse, so that's the square root of 3 over 2. Cosine is adjacent over hypotenuse, 1/2. Notice the sine of 30 is equal to the cosine of 60. Cosine of 30 equal to the sine of 60. The complements have opposite values for sines and cosines. And then, let's see, tangent is for 60 is opposite over hypotenuse, opposite over adjacent, so square root of 3. All right, and so then these are simply just the reciprocals, so that's going to be 2. This one, I'm going to flip, that's 2 square roots of 3 over 3, over 3. This one I flip. Remember, this originally was 1 over the square root of 3, and we simplified it, but thinking about this one, makes it easier. This is just square root of 3. All right, this one, yes, we simplified it to square root of 2 over 2, but if we think about the unsimplified 1 over square root of 2, the reciprocal of that is a square root of 2. And same thing here, square root of 2. Reciprocal of 1 is just 1. All right, this, when we flip that, that's going to be 2 square roots of 3 over 3 after we simplify it. Reciprocal of 1/2 is 2. And reciprocal of this is 1 over the square root of 3, so square root of 3 over 3 once we simplify it. Okay. So those are kind of important. You have to memorize them, not necessarily. You will have to quickly be able to draw a triangle, and like we see in these things here, and figure out what the reference angles are going to be 30, 45, or 60 almost all the time. So reference angles, let's talk about those. Reference angle is just the angle that the terminal side of a standard angle makes with the x-axis. It's really important that we don't talk about this angle up here or this angle over here. Of course, we know those are the same. That's not the angle. That's not the reference angle. It's always the angle that's formed by the terminal side and the x-axis. So we always draw our triangle down to the x-axis, down to the x-axis, up to the x-axis, or up to the x-axis. So this is in the different quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So even though they ask us this angle, they might ask, oh, what's the sine of theta? Our reference angle is going to have the same sign, sin, as the sine of that angle. So the only thing is this is an acute angle, so it's not going to have like the sine or the cosine can't be negative for that acute angle. But for, so we always think of that as being in the first quadrant so when we think of this angle. But we assign a negative to the lengths of their sides. So I think this will become more clear once we do a couple of examples. So fine, now, so I know we were talking about how in the previous page, how we're going to be dealing with triangles sort of by themselves. And if that's the case, we want to think about SOHCAHTOA. But when we go back and we talk about reference angles, then that's a little something different. Reference angles are dealing back with our Cartesian coordinate system. Okay, so find the reference angle for the following angles. So 85. So think about 85. 85 is in the first quadrant. They're the same. So the reference angle is actually 85 degrees. All right, 148. All right, so that's in here, right? It's less than 180. So we're in the third quadrant. The second quadrant. Our reference angle is how much more we have to go up to this 180 degrees. So how much shy of 180 is this? And that's 32. So our reference angle will be 32. Now we're just practicing them here, but more often than not, our reference angles will be 30, 45, and 60. Okay. So 207, think about that. That's past 180. So how much past 180 is this? In this case, we're just going to subtract 180 from this, get 27 degrees. And then finally, we're in the fourth quadrant. How much shy of 360 are we? So what would that angle be if this angle out here is 330? Well, we need 30 more to get to this 360, so that would be 30 degrees. Okay, they'll become second nature once we use them enough. Okay, let's move on. Find the trigonometric function values. Okay, so steps to find the trig values for common or special angles. So common angles, we think of them as 30, 45, and 60. That's angles that have those three reference angles. Okay. Find, if needed, the coterminal angle. So basically, you want to make the angle theta between 0 and 360. So if it's 700, then we would just keep subtracting 360 until we're in that range. All right, we draw the terminal side of the angle. We draw a right triangle to the x-axis, unless, of course, it's a quadrantal angle. It's, it ends on one of the axes. Find the reference angle. Determine the trig ratio using the sides of your right triangle. And then make sure you have the sign right. All students take calculus. Make sure you have the correct sign. So let's try 225. So what we want to do is draw a picture. Which quadrant is 225 in? And again, with practice, this will become second nature to you. 225 is in the third quadrant. So I'm going to draw just a generic triangle. Not drawing it to scale necessarily. All right, so the angle we're talking about is this angle here, all the way around. But we want to figure out what the reference angle is, because that's what we're going to use to figure this out. So how many degrees past 180 is that? So this is 45 degrees. All right, so I write that as 45 degrees. Sorry, that's kind of small. You can't see that very well. But I'm going to label the sides. So this is -1, this is -1, this is square root of 2. At some point, we will think of this as being a unit circle, and so we'll want the radius to be 1, but for now, we don't really need to worry about that. Okay, so now, what is the sign? The sign, in this case, because we have the Cartesian coordinate system involved here, we want to think of it as sine, that's y over r. So that is -1 over the square root of 2, or negative square root of 2 over 2. Okay? And, it should be negative in the third quadrant, so we're just kind of checking this. But I went ahead and made the sides negative. We go to the left, which is negative. We went down, which is negative. So I made the x and the y negative as they need to be. And then I didn't have to worry about all students take calculus. But if you just labeled it as 1 and 1, then you need to concern yourself with all students take calculus. Next one, -210. All right, so figure out which quadrant that's in. Draw a picture. If you want to pause the video and try it on your own. -210. So we're going this way this time, right? We're starting here and we're going in the negative direction. So it's past 180. It's up here. I'm going to draw this a little bigger than the last one. Right angle. Think of the reference angle. This is 30 degrees. So let's label the sides. So this is 1, this is 2, this is the square root of 3. Let's make them negative. This one is negative. All right, cotangent. Cotangent, think about that. That is x over y. And so what is my x? What is my y? That is going to be negative square root of 3 over 1, or just negative square root of 3. Okay, so we've got to figure out, if we need to, make the angle smaller so that it's a coterminal that's between 0 and 360. Then figure out which quadrant it's in by drawing your terminal side. Create a right triangle by drawing the triangle down to the x-axis. And figure out what the reference angle would have to be. Label the sides of the triangle. And then find what the trig ratio is. All right, so 420. Think about where that is. Now, 420 is bigger than 360. So subtract 360 from 240. So 240 minus 360. And that gives us 60 degrees. So that means we're here in the first quadrant. All right, so our reference angle here is 60 degrees. Let's label it. We have a 1. We have a 2, we have a square root of 3. Secant, think about what secant is. Let me get rid of that. Secant is r over x. And so now I just figure out what my r is and what my x is. So this is going to be 2 over 1, or just 2. All right, try this next one. Draw a picture. Negative 60, we're down here. Reference angle of 60 degrees. It's negative, but the reference angle is just 60. All right, label the sides. We have 1, we have 2, we have negative square root of 3 because it went down. And cosecant, that is r over y. And so we have 2 over negative square root of 3, and then we just simplify that. That's going to be 2 square roots of 3 over 3. Oh, but don't forget, it's negative. Okay. Makes sense? All right, next one. Find all possible measures between 0 and 360 of each angle. So in other words, we have an sine of an angle equal to 1/2. So where will that be? So first of all, which quadrants could this angle be in? The sine of the angle is positive. So think about which quadrants we're in, referring back to all students take calculus. All right, so, and also think about the sine. The sine is y over r. So think about y and r. Think about what, for all of these, we're going to have our reference angle is going to be 30, 60, or 45. So I'm going to draw, I know this is in the first quadrant and in the second quadrant. Sine is positive. So I know I'm in those quadrants. So I'm going to draw a picture. All right, this is 1, 2, square root of 3, 1, 2, negative square root of 3. So what is that reference angle that would result in that triangle? And then what's this reference angle? So they're both reference angles of 30. So this one's in the first quadrant, so definitely 30 degrees. But this one's in the second quadrant. Yes, the reference angle is 30, but what we're asked to find is, we're asked to find that angle, right? Let's see if my pen will work here. We're looking to find that angle. And that angle is not 30, right? That angle is 150 degrees. 30 degrees shy of 180, if you want to think of it that way. Okay, so these are our two angles that theta could be. Both sine of 30 and sine of 150 are 1/2. All right, tangent equals tangent of alpha equals 1. So remember, the tangent is y over x. And where is the tangent positive? So tangent is positive in the first quadrant. and in the third quadrant. And so tangent, that means y and x are the same, so that's 1 and 1, -1 and -1, and square root of 2, if that helps, square root of 2. And so what is our reference angle? That is 45. So we're in the first quadrant, so we definitely have 45 degrees. And then what is that angle, right? That's what we want to think about. That's 225. Okay? It's a little, I'm getting a little tight in here. Let's see. Let's secant. So secant, that's r over x. So you think about r is the square root of 2, x is 1. We'll think about r as being positive and x being negative. That probably helps. So where is the cosecant? Secant. Where's the secant negative? So the secant is negative in the second and third quadrants. I'm just drawing in triangles, kind of generic triangles here. Both right angles are there. And so square root of 2, all right, so that's going to be at the 45, right? Because square root of 2 deals with 45. Square roots of 3 deals with 30, 60, 90. So I know this will be square root of 2, 1, -1, -1, and square root of 2. All right, so what are these angles? We're looking at first that angle, that's 135. And then we're looking for the angle that goes from here all the way down there, and that one is 225. Same as what we saw in the previous one. Okay. All right. Cotangent is equal to -1. So think about which quadrants we're in. Where's the cotangent negative? It's the same as where the tangent's negative. And that is in the second and fourth quadrant. So we'll draw triangles in there. And cotangent, that is x over y. And so we have -1 over 1. So we have -1, we have 1, we have -1, and we have 1. So what angles are those? Yeah, if we want, we could put in square root of 2 here and square root of 2 here. And so that one is going to be 135 again. 135 is up there. And then all the way around there, that one's going to be 315. 45 degrees shy of 360. All right. So this one is 45 degrees shy of 180. This one's almost all the way around, but it's 45 degrees shy of this 360. So that reference angle is 45, and so is that one in there. All right, cosecant. Remember cosecant, that's r over y. And the cosecant, where's cosecant positive? That's the same place that sine is positive. So we're dealing with quadrants, again, 1 and quadrants 2. Let's draw some triangles in there. So we have this and this. Now this one I would recommend sort of, this is a simplified version of the ratio. Isn't that the same as 2 over the square root of 3? So I think it would be, it's easier to do these problems if you, this is the simplified ratio. Go back and think of it as the unsimplified one, right? You'd multiply top and bottom by square root of 3 to get this thing. But it is, I think, easier if you deal with like those simple numbers there. And so that is r and that is y. All right, so then we have to think about, all right, r is 2, y is the square root of 3, square root of 3, and 2, so this is 1 and this is -1. So what is our reference angle? And this one is actually one of our answers because the reference angle, it's in the first quadrant. So that should be 60 degrees. And then what would that angle be all the way over to there? This is also 60, the reference angle, so 60 shy of 180, that's 120. Okay? All right, let's go on now to page 3, if I can find it here. Page 3. All right. So page 3, use your calculator to approximate to the nearest tenth ratio values of each trig ratio. Okay, so I would say pause the video, do those in your calculator, and then unpause the video. And I'm just going to run through them quick. Tangent 45, that's just 1. So you should be able to figure that one out without a calculator. But the rest of these, none of these are. Oh, this one is. But none. These other 3 are not. You could not do them because the angles are not our common angles. They don't give us a reference angle of 30, 60, or 90. This one does, but it's still asking us to do it as a decimal. Just use your calculator. So this one is negative 0.545. Cosine of negative 183, that's negative 0.999, close to negative 1. And this is just practicing using your calculator. Now this one, you don't have a button cosecant, so you'd have to do the sine of this, convert all of these, right, 2 degrees, so, take minutes, divide that by 60, divide this by 3600 to get decimal equivalents. Take the sine of that, because your calculator won't do cosecant, and then do the reciprocal. So you should get negative 1.455 for that. And then similar for this, we don't have a cotangent of negative 120, so you do the tangent of 120 and then do the reciprocal. So 0.577. Okay. Next one, on your calculators, the sine, cosine, and tangent buttons have second functions, which is sine, inverse cosine, inverse tangent. Now, those things do not mean 1 over sine. All right, that is not what this button is doing. It's not doing the cosecant like up here. So you can't hit that button. This is the inverse function. So instead of putting in an angle and getting out a ratio, your calculator will give you some kind of ratio as a decimal. Instead, the inverse sign, you put in the ratio and you get out the angle. All right, so to try that, let's practice some of that. So if you do in your calculator cosine of 60 degrees, you'll get 0.5, or 1/2, right, 0.5. If you do the inverse cosine, so hit second cosine and then type in 1/2 or 0.5, it will give you 60 degrees. So it's a way of, it's not the reciprocal, it's not this, it is the inverse function. So normally we put in an angle, get out a ratio. Now we reverse the inputs and the outputs. We put in a ratio and get out the angle. All right, so tangent of 45, well, we know that's 1, right? You could try that in your calculator to verify that, but tangent of 45 degrees is 1. The inverse tangent of 1, that's 45 degrees. Now, we saw on the previous page that it could be more than one thing, right? Could be more than one thing. This is the same kind of thing, right? We're doing what angle has a sine ratio of 1/2. It's really essentially doing the same thing here. But this one, when we do the inverse tangent, we'll get to it more later, but when we use that, it restricts it to certain quadrants. At this point, we're going to be restricting it to quadrant 1. We'll get to more complicated ones later. All right, so let's just practice some of this. In your calculator, this is a big, long, nasty ratio. If I said the sine, the sine of theta is equal to this thing, then what would the angle theta be? And again, we're keeping it to the first quadrant. So plug that into your calculator. It gets pretty close to 54 degrees. All right. This one, again, we don't have a secant button in our calculator, but we can say, all right, this is the ratio for a secant we could say cosine of theta equals the reciprocal of that, 1.141213562. Okay, so that's the reciprocal of that, right? If secant is equal to this, cosine is equal to 1 over that. So that means we could do, all right, so theta is equal to the inverse cosine of that ratio, 1 over 1.414213562. All right, and that would give us about 45 degrees. All right. Tangent, do that one in your calculator. Gives us an angle of about 32 degrees. Okay. So we're talking now about some word problems dealing with slopes going uphill or downhill in a car. Okay. So if we think about a positive angle, then we're going to be thinking about you're parked up, going up the hill. A negative angle means you're going to be going down the hill. So when a car travels uphill or downhill on a road, it experiences force due to gravity. This force in pounds is called the grade resistant and is modeled by F equals W sine theta. All right, when theta is the grade, in other words, angle made by the horizon, and then theta is greater than 0, we're going uphill, and when theta is less than 0 degrees, or it's negative, then we're going downhill. And W is the weight of the car. All right, so calculate the force, calculate the force to the nearest 10 pounds for a 5,500 pound car traveling an uphill grade with a theta equal to 3.9 degrees. So pause the video and just plug that in and see how you do. All right, F is equal to the weight, 5,500 pounds, sine of theta, which is 3.9 degrees. And so that's just pure calculator work. You're just plugging that into your calculator. That's to the nearest 10 pounds, that's 370 pounds. All right. All right. Now, a 2,400 pound car traveling downhill has a grade resistance of negative 288 pounds. What is the angle of the grade? So let's draw a picture for this one. Right, we're going downhill, it's negative. That's what we're looking for, theta. And you know, I don't know, I can't draw a car, so here's the car. All right, so we just plug in what we know. We know the force, so we just plug it in reverse. Negative 288 pounds is equal to 2,400 pounds, and then sine of theta. Okay, so the first thing we're going to do is we'll solve this for theta, sine theta, by dividing by 2,400 pounds. So that's negative 288 divided by 2,400. The pounds cancel, right? The sine ratio is always dimensionless, so the pounds over pounds would cancel, so that's good. And so how are we going to find theta? Theta is equal to the inverse sine of that ratio, negative 288 over 2,400. Okay? So you may not really understand what this whole grade resistance is and the force and that kind of thing. Don't worry about it. You just plug in, what you know. We'll talk more about these kinds of forces and normal forces and resistant forces in a later section when we get to vectors and that kind of thing. So don't worry about it too much. All right, so what is it? Plug that into your calculator. We end up getting negative 6.9 degrees, I think, to the nearest tenth of a degree. All right? All right, and so your homework is listed here. That is the homework due next class.